Hello, folks, from friends. Welcome to Science Talk. I am your host, Jim Massa. I want to discuss with you what you see here. As climate change worsens, a cascade of tipping points ever looms. This is kind of an analysis, and it was printed in the online journal E360 Yale.edu. So this is through Yale University. e360.yale.edu. New research warns that the Earth may be approaching key tipping points, including the runaway loss of ice sheets that could fundamentally disrupt the global climate system. A growing concern is a change in ocean circulation, which could alter climate patterns in a profound way. Let's stop there for a moment. There are times when I wish I wasn't right. This is one of them. I have been, those of you who have followed my channel know that I have been talking at great length about changes in the ocean circulation, about what happens if the Atlantic meridional overturn circulation slows down and or stops. It will have profound effects. And oftentimes you do not see a lot of climate scientists factoring that in their analyses. So this to me is kind of the key aspect, the key factor to everything, along with what's happening to the ice sheets. But this whole ocean circulation, the conveyor belt, as it's colloquially called, is a heat distribution mechanism for the planet. Not only that, where it branch upwells in the Antarctic divergence zone, bring in much needed nutrients to the surface waters there, and that fuels the food web of the Southern Ocean. You shut down AMOC, that goes away. All the baleen whales that thrive down there will no longer be able to sufficiently feed. That will lead to mass extinction. When you find that there's no deep water formation and circulation, the ocean doesn't what we call ventilate. In other words, there's no deep overturn mixing. So then you start getting stagnant layers. You're probably going to get some layers that are anoxic, hypoxic, and so forth, which will profoundly affect organisms found there, and not to mention changes in the ocean chemistry. This is a big deal. Now, this report came out towards the end of last year. There's been some new developments since then, and I'll have some reports for you of new tipping points. I am of the opinion that I used to say that I think we're past the tipping point. If not, we're close to it. I have reassessed, and I'm now basically saying we are past the tipping point. For sure. That's my assessment. It's not so much that, oh, if not, we're close. No, I think we've blown past them. Several tipping points. And that's what I want to look at here in this analysis. So the most alarming science surrounding climate change is the discovery that it may not happen incrementally as a steadily rising line on a graph, but in a series of lurches as various tipping points are passed. Now comes a new concern. These tipping points can form a cascade, with each one triggering others, creating an irreversible shift to a hotter world. A new study suggests that changes to ocean circulation could be the driver of such a cascade. I have some report coming down that basically shows in one report that the researchers are saying that if you have certain carbon dioxide levels, instead of the temperature increasing linearly, it's going to increase exponentially, but at a high exponential rate. And some of the models are showing that at certain levels of warming and of CO2 concentration, they're saying, this one group of researchers saying an increase of 9 degrees C by 2100. That's game, set, and match, if this is true. So now, before going further, so why do so many models seem to extrapolate to different levels of temperature increase globally by the end of 2100? You know, you see 2, 3, 4, 5, 9. You see all these different measurements or estimations. They're not measurement, they're estimation. Why is that? The key is, how do these researchers treat the cloud parameter? Modeling for clouds is extremely difficult. And that's where we see a lot of the uncertainty. And that's a big problem. You know, and scientists are trying their best to understand better the role of clouds, the interaction. You know, for example, the bottom of clouds can retain heat. The top of clouds can reflect sun energy. So is heat lost or kept? Things like that. Depends on the type of clouds. Depends on where they're located in the troposphere. What's the moisture content? It's a very difficult question. At least as an oceanographer, I know the water is wet. It's a little easier to deal with. So a group of researchers led by Tim Lenton at Exeter University in England warned in a paper, that's now a landmark paper, 11 years ago, about the risk of climate tipping points. This puts about 2008. Back then, they thought the dangers would only arise when global warming exceeded 5 degrees C, which is 9 Fahrenheit, above pre-industrial levels. But last week, Lenton and 6 co-authors argued in the journal Nature that the risks are now much more likely and much more imminent. Some tipping points, they said, may already have been breached at the current 1 degree C of warming. 1 degree is the low end. We're really more at 1.3, 1.4. The new warning is much starker than the forecast of the IPCC, which critics say has until now downplayed the risk of exceeding climate tipping points, in part because they are difficult to quantify. I can also tell you the IPCC is being mostly a political body, answering to heads of states or at least reporting to heads of states. That's part of the reason for their downplaying the risk assessment. One thing that annoys me is that you don't see the IPCC really discussing in any detail at all, if at all, of methane. Potential tipping points come in 3 forms: runaway loss of ice sheets that accelerate sea level rise, forests and other natural carbon stores such as permafrost, releasing those stores into the atmosphere as CO2, accelerating warming, and the disabling of the ocean circulation system. Okay, translation about this aspect here. Forests and other natural carbon stores. Right now, they are carbon sinks. They are becoming carbon sources. So instead of sequestering carbon out of the atmosphere and out of the system, they're putting it back in. That's what that means. And you can see a little kind of a subtitle here. Researchers' biggest fear is for the future of the ocean circulation system, which moves heat around the world and may dictate global climate. And I'm an oceanographer, so this is in my wheelhouse, if you will. I've been making this argument for years. Yes, I study sea ice and all that kind of stuff, but on the other end of the Arctic, you got the Fram Strait, and the Fram Strait is where AMOC starts. So it's tied together. And whatever the Arctic dipole is doing will determine if ice is shoved down the Fram Strait or kept within the Arctic Ocean basin. But I've been making this argument for years that if you really want to get a handle on what the hell is going to happen globally in climate terms, understand better, study better what's going on with the ocean circulation system. I've been making that argument for years. So yes, it's important to study what's going on with crops and and fisheries and, droughts and heat wave. That's all important. I'm not downplaying all the excellent work that's being done out there. It is important work, and it's good that they are being done. But I still say it comes down to AMOC. Researchers once considered these tipping points to be largely independent of each other. Now they warn the world faces a cascade of abrupt shifts in the planet's climate system as global warming takes hold. We might have already crossed the threshold for a cascade of interrelated tipping points, they wrote in Nature. This could trigger a shift in the state of the Earth system as a whole. One of the authors, Will Stephan of the Australian National University in Canberra, in an interview with Yale Environment 360 mentioned. Now, when I did my oscillatory system video series, I talked about ENSO, and I talked about the Pacific Decadal Oscillation. I talked about the Arctic Oscillation, North Atlantic Oscillation, et cetera, Indian Dipole, right? Indian Ocean Dipole. What I tried to stress in all of that, they don't just occur on their own. There is what's called teleconnections. In other words, all these big oscillatory systems, they're taking place pretty much in the atmosphere. Well, the atmosphere covers the planet. They're all in a manner connected, communicating with each other. So that what goes on with the PDO will affect what goes on with the NAO, which affects what goes on with the AMO, etc. Earth is a complex system, folks. The biggest fear is for the future of the global ocean circulation, which moves heat around. They say melting Greenland ice in a warmer Arctic has driven a key component of ocean circulation to a 1,000-year low. Further decline, which would lead to a shift in heat distribution around the planet, could trigger forest collapse in the Amazon, cause near-permanent drought in Africa's Sahel region, disrupt the Asian monsoons, rapidly warm the Southern Ocean, which would cause a surge in global sea level as the West Antarctic ice sheet disintegrates, and potentially shift the planet to a new climate regime they call Hot House Earth. Now, way back in early Earth's history, there was the snowball Earth hypothesis, where basically Earth was a big snowball, including snow down to nearly basically the equator, or almost to it. And due to outgassing, volcanic activities, tilts in the orbital mechanics, the snow eventually melted, the ice eventually gave way, and Earth got out of the snowball situation. Some folks say, well, not so much a snowball, but a slush ball. Be it as it may. If you were to dig through my video library, I talked about that way back when. Probably one of the first videos I did when I started this channel, discussing about hypothesis. But here's another key thing, though. And this is, yes, I understand what they're saying here about all these potential eventualities. But Wally Brokish demonstrated quite well that if the conveyor belt shuts down, the planet goes into an ice age. Now, granted, the situation is different now because there's so much thermal energy, so much thermal inertia in the system that, if the conveyor belt shuts down now, we don't immediately go into an ice age. It may take a millennium, singular, at least. It may actually take several centuries for the conveyor belt to come to a full stop. As it is right now, the deep water formation in the North Atlantic is slowing, and as it sinks, it pulls the Gulf Stream with it. Well, if the sinking is slowing, so is pulling the Gulf Stream, so the Gulf Stream is also slowing. Starting to see a change in the temperatures in like Scandinavia, as an example. So here are some of the, before I continue going through the text here, let's look at some of the tipping points that are mentioned in this graphic that we see here. Let me see if I can It doesn't enlarge, and that actually makes it smaller. Okay, so let's start with A. A is the Amazon rainforest. We'll see frequent droughts. And the orange dots with the letters included, those are the identified tipping points. The orange lines are the connectivity between the tipping points. So, A is the Amazon rainforest with frequent droughts. B is the Arctic sea ice, reduction in area. And you can, they've got that listed up here off Franz Josef Land, which is there. You could also as easily put that over here in the Chukchi Beaufort Sea. Here would be the Barents Sea. Okay? So they could have easily put it over here. And or for that matter, over here in the lab test. In the east side, showing drastically reduced sea ice extent. C is the Atlantic circulation. Okay, they probably should poof. It starts up here more likely, but that's what they've stuck it there. D is the boreal forest. Again, D, the boreal forest. They could have easily put it across Scandinavia, across Russia, into Alaska, Yukon, etc. A boreal forest. Fires and pests are changing. It's also drying out, which leads to more fires, right? The Atlantic circulation, by the way, is in slowdown since the 1950s, and the slowdown has increased in the last 10, 20 years. F, coral reefs, large-scale die-offs. Okay? Obviously, that's for the Great Barrier Reef. G, the Greenland ice sheet. H is the permafrost. Anywhere where there's frozen ground, it's in danger of thawing and releasing all that methane. And what is happening now in Siberia? We had only the second time ever a temperature of 100 degrees or more Fahrenheit was ever recorded in the Arctic. And that happened recently in Siberia. The other time was going back to 1915 in Fort Yukon, Alaska, where it got to 100 degrees. And it's on fire. The Siberian forest is on fire. Then we got the West Antarctic ice sheet, and then we got Wilkes Basin. So the ice loss is accelerating in both of these locations. So what's the connectivity? Okay, let's start with the Atlantic circulation. As this flows, it's going to directly impact what happens in Antarctica. Okay, it's going to impact what happens in the Amazon. And the arrows indicate the direction of impact. So to affect the Atlantic circulation, we are doing what? We're adding fresh water into the North Atlantic. Fresh water from the melting Greenland ice sheets, fresh water from when the sea ice, instead of freezing, it stays liquid form, the salinity is reduced. Because when you form sea ice, first of all, the ice will freeze at a lower temperature because of solute impact. In other words, what's called freezing point depression. The presence of dissolved solutes will lower the freezing point and will, on the other end, boiling point elevation will increase the temperature at which it boils. So it has to cool down further to form the ice, but when it does form the ice, the salt is rejected, called brine rejection. So the liquid water portion, the density is increased, so it will sink. But now if you don't have the sea ice forming, you have reduced salinity, reduced density. Not as likely to sink. Add in throwing a pile of fresh water on top of the ocean, you're really reducing the density. You're really not going to sink. So that's the connection from the ice. And of course, they communicate with each other there. And, then they're showing a connection between what goes on in the Arctic sea ice with the permafrost and the boreal forest. Now let's see it's interesting that there's no connection with the coral reefs, at least in this diagram. So that's kind of an interesting one. So Mike Hulme of University of Cambridge dismissed the new analysis as speculative opinion from a small group of self-selecting scientists. He added there are no new research findings presented here, and that many Earth system scientists would challenge the view that the Earth is close to crossing major tipping points. Lenton and his co-authors acknowledge there is speculation involved, but argue that given its huge impact and irreversible nature, to err on the side of danger is not a responsible option. Welcome to scientific debates. This is what goes on. You're gonna some people say, they're gonna be a little more conservative in an estimate and say, no. But oftentimes, sometimes the data is there. It just needs to be re-looked at with fresh eyes, if you will. Just saying. The climate emergency is not just political rhetoric, they argue. It is now an identifiable scientific fact. Their message to the latest UN climate negotiations underway in Madrid this week, which was back in November, I think, is that the world may be almost out of time to prevent what they call an existential threat to civilization. The study was released as a new report. It said that greenhouse gas emissions have hit a record high with 40.6 billion tons of CO2 put into the atmosphere in 2019 alone. Remember, the IPCC basically issued a report saying, oh shit, we've got 10 years. They tend to underplay everything and downplay everything. So for them to say such a thing, yeah, they're running scared. Makes me wonder if this report by Professor Lenton and his team had something to do with that. Oh, the term climate tipping points first coined 15 years ago by Hans Joachim Schellnhuber, who was former director of the Potsdam Institute for Climate Impact Research in Germany. It's usually referred to as PIK, a very world-renowned research institute. Co-authored a new analysis to describe how under pressure from global warming, parts of the climate system could suddenly collapse or run out of control. Remember, I have often argued that we have perturbed the system, and Earth, in trying to find its new equilibrium point, is continually perturbed, such that the system cannot settle on its new equilibrium point. So when you got that kind of stuff going on here, you're basically getting chaos theory here. Slight perturbation, you're going to get wildly crazy different results. And we're starting to see wildly crazy different things going on. In a new analysis, the researchers conclude that of the 15 potential tipping points identified in 2008, 7 now show signs of being active, along with 2 others they have added to their list. Lenton says that doesn't mean the tipping point has necessarily been reached, but it means the system in question is showing evidence of change, of heading in the wrong direction. In other words, positive feedback loop. Which doesn't mean good things, it just means it amplifies upon itself and can run away. Right? What it said? Could suddenly collapse or run out of control. Basically referring to positive feedback loops there. 4 of these 9 active tipping points involve thawing ice. Arctic sea ice is rapidly disappearing. Ice loss is accelerating on all 3 of the planet's large land-based ice sheets. Greenland, West Antarctica, the Wilkes Basin in East Antarctica. And don't forget, ice is being lost in the Himalayas, sometimes called the third pole. Lenton says 2 of these, the West Antarctic ice sheet and Wilkes Basin, are showing evidence consistent with having passed a tipping point, meaning further ice loss may be unstoppable. You got the Larsen ice, you got the Thwaites in Pine Island, all those ice sheets are in danger of total collapse now. Greenland may not be far behind. Models suggest that the Greenland ice sheet could be doomed at 1.5 degrees C of warming, which could happen as soon as 2030 or sooner. Exceeding the 3 ice sheet tipping points could eventually cause an irreversible rise in sea levels of about 13 meters. That will take care of just about any coastal area, any coastal city. The Maldives will be drowned. Cities such as London, New York, Miami, Shanghai will be flooded. Unlike here's another little quote here. Unlike the slowly deteriorating ice sheets, passing biospheric tipping points will produce abrupt, immediate, obvious changes. It's basically causing mass die-offs. This may take centuries or millennia to play out. That's referring to the ice sheets. As the ice sheets slowly disappear into the ocean, but it will be virtually unstoppable because once a thaw sets in, the surface of the ice sheet is lowered, exposing it to ever-warming air at lower altitudes. Right? The Greenland Antarctic ice sheet is, like what, 2 miles thick? 2 miles thick, you're up in the atmosphere. Temperatures get lower as you go up in the atmosphere. Well, we start melting in, and the top of the ice sheet is at lower and lower elevation, it's going to encounter warmer and warmer air temperatures, which will help the melting move along. 4 more of the already active tipping points involve the biosphere and its stores of carbon. The Amazon is suffering recurring droughts and forest dieback. In the boreal forests of the far north, rising temperatures are triggering epidemics of forest fires and pests. And as the permafrost thaws, we don't know what pandemics can be released from the thawing permafrost. Permafrost is thawing, releasing methane. A greenhouse gas is 28 times more powerful than CO2. In the tropics, coral reefs are suffering massive die-offs, bleaching. Ocean waters are getting more acidic. It's killing off the ecosystems there. There's that quote again. That passing the tipping points, we will see obvious changes straight away. Deforestation in the Amazon is already reducing rainfall, lengthening the dry season to a point where the rest of the trees die or are consumed by fires. And don't forget what Bolsonaro is doing. We're cutting the crap out of everything. He's cutting all the trees down. Carlos Nobre of the University of Sao Paulo, who is not involved in the present analysis, says that when the dry season becomes longer than 4 months, tropical forests turn to savanna grasslands. He put the Amazon tipping point at 40% tree loss, a figure that changing global climate could reduce to between 20 and 25% by 2050. This is disturbingly close to the current total loss, which is estimated to be approaching 20%. Here's a forest fire burning away in the Amazon. Could be natural, could be from clear cut. And by the way, if you look here, see all these trees that kind of look gray here, right? All these trees are gray, they're dead. Those are dead trees, which means they're very dry. They can easily go up in flames. And it says abrupt releases of CO2 from these natural carbon stores would drastically reduce the leeway the world has for avoiding global warming above 1.5 degrees, the preferred target set by the 2015 Paris Agreement. Good luck. We're at 1.3, 1.4. We're going to blow past that. Sorry, we just are. Now the question is, can we keep it below 2? That'll take some doing. We may even blow past that. Even Michael Mann is now acknowledging that we'll probably go past 2 degrees C by 2035. And he tends to, I have great respect for Dr. Mann, but he is a bit, even though he came up with the hockey stick graph, he does tend to be conservative in his extrapolation. That's fine. You know, he likes to go on that side of things. That's fine. Not an issue here. But if he's saying 2035, we need to listen to him. Maybe sooner, maybe later, but we need to listen to him. Because he's basically saying, yeah, if things go as continue, we are going to go past 2 degrees C. That is, in essence, what he's saying. When that happens, that's anyone's guess, but that is, in essence, what he's saying. So that, and Dr. Lenton goes on to say that probably requires limiting future CO2 emissions to about 500 billion tons, roughly 12 years emissions at current rates. But abrupt forest dieback in the Amazon and boreal forests, coupled with methane emissions from thawing permafrost, could use up 300 billion tons of that emissions budget. 60%. Doesn't leave much wiggle room. The basic mechanisms behind these tipping points have been well known for some years, though the predictions of the time it will take before they are activated have become much shorter. The real new concern, says Lenton, is the identification of the potential for tipping point cascades, in which breaching one tipping point triggers breaches of others, leading to a rapid escalation of damage. Lenton, Stefan, and others argued last year that 2 degrees C of warming could activate a domino-like cascade that could take the Earth system to even higher temperatures, what they call the hothouse Earth, which would be irreversible even if greenhouse gas emissions were brought to zero. The linchpin of one such cascade, they say, is the 9th tipping point that they identified to be active, a critical feature of the global ocean circulation system centered in the North Atlantic, known as AMOC, the Atlantic Meridional Overturning Circulation. You see another quote here. In our view, the evidence from tipping points alone suggests we are in a state of planetary emergency. The AMOC is currently initiated by evaporation of warm water moving north, which leaves behind saltier, denser water. Also, when the Gulf Stream reaches the Jin Sea, not only is the evaporation, but it's giving off its heat. So yeah, evaporation leaves salt behind because evaporation only puts freshwater vapor into the atmosphere. It doesn't put salt in the atmosphere. It puts freshwater vapor, leaving salt behind. So yes, you're increasing the salinity, which increases the density. Couple that with giving off its heat, latent heat energy, which is why Scandinavia and the UK are warmer than it should be for those latitudes. So you have the combination of evaporation and giving off its heat that makes that water cold and very salty, very dense, which enables it to sink. Okay, so the denser water sinks to the seabed, is responsible for driving the ocean circulation, distributing heat around the globe, maybe the prime regulator of the climate. Stefan Ramstorff is an oceanographer at the University of Potsdam and a co-author of this new analysis, said the AMOC stands at the center of tipping point cascades because of its large-scale heat transport. It is, he says, the main reason why the northern hemisphere is warmer than the southern hemisphere, but it is being disrupted. Arctic warming and Greenland melting are driving an influx of fresh water into the North Atlantic. The fresher water is less dense, sinks less, as I've been saying for ad nauseum. Ramstorff calculates that as a result, the AMOC has weakened by about 15% since global warming took hold in 1975. It is now at its weakest in the past millennium or even longer. 2 words to express my reaction. Holy shit. Seriously, this is a holy shit moment. The decline of the ocean circulation threatens to trigger other tipping points elsewhere. Slowdown of the AMOC reduces rainfall over the Amazon basin, increasing the probability of crossing a tipping point there. In other words, if the Amazon dries out, it leads to fires. It could also mess with the monsoon systems in Asia and West Africa, triggering droughts in the Sahel. By bringing warm waters into the Southern Ocean, it would further destabilize ice in Antarctica, unleashing acceleration in global sea level rise. Well, if it, now this one I kind of question a little bit, because if it slows down or stops, that warm water is not going to reach Antarctica. So you're not going to necessarily get that warmer water melting the ice from underneath. Most climate models predict a continued weakening of AMOC through the 21st century. It remains unclear how close it might be to a tipping point, the researchers admit, but Lenton says that historically the AMOC appears to jump between different stable states. Okay, Wally Broker demonstrated that AMOC can shut down in a matter of decades. To use Wally Broker's own word, like flipping a switch. I think that is the reference here that Lenton makes. The question, says co-author Johan Rockström, who's director of the Potsdam Institute for Climate Impact Research, is what are the pressure points where we might cross a threshold and trigger a state change? Now, let's take a moment to look at this graphic, which is showing temperature anomalies from 2014 to 2018 in degrees Fahrenheit. It's not Celsius, degrees Fahrenheit. So basically, 1 degree C is 1.8 Fahrenheit. So 3.6 Fahrenheit is 2C. So we're talking about, on a scale, this would be plus or minus 2.1, 2.2 C. Okay. Meltwater from Greenland has created a pocket of cold, fresh water. That's this right here. It comes off this way here. Okay. And where you got, freshly melted water flowing in, it's going to be cold in temperature, and there's going to be some of that coldness is going to be felt in the atmosphere right above that newly inputted cold water. That's why when you look at a lot of these temperature graphs, there's always this persistent blue spot here in the North Atlantic, because this is reflecting the meltwater coming off Greenland. But when you look at this here, okay, basically the entire planet is warmer than average, than usual, right? These are temperature anomalies. In other words, 0 means there's no anomaly. It means it's about historic averages. Aside from a little spot here in the Pacific, which can be related to the PDO and ENSO, and this here in the North Atlantic, most of the planet's surface is experiencing warmer than usual, warmer than historical average conditions. But look here at, this is the Arctic. This is coming over into Siberia, into Scandinavia. This is where we see the hottest deviations from normal. The highest anomalies are here. The Arctic is warming. Some scientists now say 3 times faster than the rest of the planet. Definitely twice as fast. Some is now saying 3 times faster. So in the face of this threat, the researchers wade into the political debate about whether, as the European Parliament voted last month, the world should declare a climate emergency. And hence the quote from above. They justify stating or calling for a planetary emergency by attempting to define a climate emergency in mathematical terms. Hey, as scientists, we use math. As a product of the extent of the threat, the probability of it happening, and the urgency defined as how much time we have left to act. They argue that the current climate crisis fits that definition, with huge risks, increasing likelihood, and time fast running out. And as you can expect, such claims are going to be poo-pooed, I'm being polite, by other colleagues. And this gentleman, whom is back at it, says such a calculation is deeply misleading and dangerous. It is a bid by these scientists to place themselves as arbiters of whether or not we are in a climate emergency. It is for society as a whole to decide what an emergency is, not scientists. Okay, I have something to say about that. Us scientists are the experts. We present our findings. Now, if you want to have a debate saying, is this a planetary emergency or not, I guess you can have that debate. But to try and say that let society decide as a whole, are you saying that they are suddenly all experts in climate matters? Us scientists, we are the experts. We present our findings. We make our recommendations. Now, if the society, let's say we tell them, things are really dire. We need to drastically change how we do things and do a society. And they basically say, no. Then what? We're kind of doom ourselves, aren't we? So it is the role of scientists, in my opinion, it is the role of scientists to state, these are our findings, these are our recommendations, these are our concerns, these are our warnings. You need to pay fucking attention to it now. To be blunt. So, this Dr. Whom, he's probably one of those 37 authors of papers who say humans aren't doing anything to the planet. Be that as it may, I don't know. He's kind of playing the role of the naysayer here. All right, fine. Have the healthy debate. But be careful with some of the rhetoric. So Lenton responds, I am definitely not bidding to be an arbiter of climate emergency. I am just trying to offer some scientific support for the already loud societal claims for climate emergency. Referring to ongoing global youth protests demanding action to reduce greenhouse gas emissions, he states, the school kids are right. Boom is also concerned about unintended consequences, such as encouraging politicians to embark on geoengineering projects like deploying the devices to shade us from solar radiation. Okay, I like to be fair and objective. I agree with him on that one, because geoengineering schemes are just that. They're schemes, they're bullshit, they'll never freaking work. So on that point, I am 100% with him. He says, calling a planet-wide emergency can only accelerate the day when solar climate engineering is actively pursued. So then what do? We have to call attention to the fact that we're really in deep shit right now. It almost sounds like he's advocating, stick your head in the sand. No. So what you have to do is you have to convince the politicians not to pursue such schemes, but to pursue things as going with green energy, renewables, until you make the transition to like battery cars, improve fuel efficiency, put solar panels on the rooftop of every home, have a wind turbine places, use wave action to generate energy, or like in Iceland, use geothermal. So he makes it like an either or. So on that point, I'm going to take issue with him. The first point about, Bart, yeah, he's I'll agree with him 1,000% on him. So Lenton says he remains opposed to geoengineering. Good for him, which he calls as risky as the risk we're trying to avoid. Spot on correct. Okay. For example, I did a story some time ago about, one of the schemes was build a concrete wall around Antarctica. Are you fucking kidding me? First of all, how are you going to get the materials there? Think of the energy to get the materials there. Think of the energy required to, obtain the material, the cement dust and the rocks and the gravel and mixing and pouring, and then you got to engineer it. How are you going to divert the water as you pour the form? I mean, good God! Then you have to calculate the size of this concrete wall so that it can hold back, I don't know, the whole freaking ocean. So that's I ripped that proposal to shreds. So Dr. Hulme and Lenton signed a joint statement, which was published in Nature Climate Change back in 2015, warning of just such an eventuality. Lenton says that he remains opposed to geoengineering, which he calls as risky as the risks we are trying to avoid. He is correct in that assessment. He thinks the threats the world faces are too great for scientists to stand on the political sidelines, especially given the world's current failure to act to head off climate disaster. And we're seeing more and more scientists get involved. They're not just doing their research and publishing in the journals. They're actually getting out there, sharing the findings that they're arriving at, and telling us the warnings that we need to all hear. So this is a good thing. And as I said, you're also part of this. You're also seeing more and more scientists giving interviews, discussing their work. And I often cite these interviews in some of my other video segments I create. The current approach of the UN Climate Change Convention is a failure, says Dr. Stephan, but he is not without hope. He believes declining fertility, innovation towards low carbon energy, and growing movements for greener consumption all suggest that human society may be reaching its own tipping point in responding to the crisis. The bottom line, he says, is that we need to reach a social tipping point before we reach a planetary one. So yes, it's encouraging to see the innovation towards low carbon energy, renewables, and more people becoming more conscious and embarking on greener consumption. The question is, will it be enough? Is it too little, too late? So I wanted to bring this video to you, discussing the situation with the tipping points, and that this is extremely serious. And we're starting, when you take all the positive feedback loops that are happening, the amplification of those, and that the increase in temperature and CO2 and ice melt, etc., is now increasing exponentially. The alarm bell needs to be set off, and it's now up to politicians to get off their duffs, get off their asses, listen to the scientists, enact some of the policies the scientists advocate for. So there you have it. Thank you for your time. Thank you for your attention. We'll talk soon. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.